Okay, here we're going to take a look at solving equations in one variable that have fractions in them. If you notice, I have my graphing calculator out because it's a great tool to help me with fractions if I encounter a computation that's a little sticky because it has a fraction in it. Even if you know the algorithm for it, sometimes it's just quicker on your calculator. I encourage you to know the algorithm for operations with fractions. It's very important that you do. But your calculator can help assist you appropriately as well when that fraction work sits inside a larger problem like here. So if you notice here, we're going to apply the five-step method that is pretty traditional throughout all of algebra. We're going to work it on this problem where it says 2/3 x plus 3/4 times the quantity of 16/3 x minus 9 equals 3x plus 1/3. And the five-step algorithm is right here where it says we're going to distribute, collect like terms on each side, get all your variables on one side, undo all your additions and subtractions, undo all of your multiplication and divisions. Okay, so I'll try and use the colors of ink that match the colors of what I wrote. And if we notice out of the blocks, we do see a distribution in this problem as given away by the parentheses here that will perform that. Now, good writing is always from left to right, and we start to write part of the problem from left to right until we get to the part we're going to work on. So change back over to red, and we'll do 3/4 times 16/3 and 3/4 times -9. So just on my calculator, you'll notice I'll have 3/4 times 16/3. Excuse me, not 16/33. And I'll hit enter, and voila, it just happened to be a whole number, which is nice. And we're obviously thinking the x when we do that multiplication. And then on the next one, we're going to do 3/4 times, let's call it -9 and associate the sign with it and get -6.75. Hitting math, enter, enter converts that over to a improper fraction, -27/4 or -27/4. And then I'll go back and continue to pull down the parts of the problem I haven't done. So, step 2 says that we will collect like terms on each side, and I will look to do that here in blue, and I'll see that I have a 2/3 x term and a 4x term. I obviously can't collect in this 3x because it's not on the same side. So I will just use my calculator to assist me on that. I think it's 2/3 plus 4, which is obviously 4 2/3. But I will just real quickly use my calculator to get the improper fraction for that. I notice that it is in fact 14/3 x. And again, bringing down the parts of the problem that I have not worked on, just to work in that good line-by-line writing fashion. And that's going to bring me to the next step of get all your variables on one side. Okay, and if we notice here, in fact, we do have x's on the left and x's on the right, so we're going to rectify that by annihilating a pile. I'll take a moment and say that I'm going to get rid of this 3x by subtraction. This step where we get our variables on the one side is always done by addition and subtraction. So I will do that on both sides. Cancels on the right. I'll just go to my calculator. If you notice, I have 14/3 on my calculator already, so I'll just type -3. Math, enter, enter. And that gives me 5/3 x. And then back to bring down the rest of the problem that I have not done any work on. Okay. So now I'm going to look at undoing all of my additions and subtractions. And from there, I do notice that I've got a -27/4. So I will undo that with its inverse operation of adding 27/4 to both sides. That golden rule of algebra, whatever you do on one side of the equation, you have to do on the other. Canceling here, we will get 5x equals another trip to my calculator for 1/3 plus 27/4. Math, enter, enter. Giving me 85/12. Should have wrote a plus sign here. 85/12, I believe is what that was. Just check again and see that that's true. Oh, I'm so sorry. Actually, for here, this was 5/3 x when I brought that down. Okay, so that takes care of that step. So now where it says undo all of your multiplications and divisions, in the higher levels of mathematics, algebra and beyond, we tend to think of work with fractions very specifically when it comes to this step. If you notice, this is multiplied by 5/3, so dividing by 5/3 would make sense. But we don't tend to divide by a fraction. We tend to multiply by the reciprocal. So instead of dividing by 5/3, I'll do an equivalent process for that, which in fact is to multiply by 3/5 on both sides. So here on the left, we cancel out the 5/3 with the multiplication by 3/5, and that will give us x equals, going to my calculator, I see that I have the 85/12 there already, times 3/5, excuse me, 85/12 times 3/5. I know a little calculator snafu there, but I worked past it. So we get 4.25. So 4.25 is a nice enough decimal to write just as the decimal. And I circle that. A little prematurely, I'm going to check that now. And I'm going to use my calculator for that. Okay? Your calculator is a great tool for checking in this case too. So if you notice here, I'm going to hit the store button, which is next to the 1, the X button, which is just down 1 and right 1 from your second button. And now I've stored that as X, so anytime I use the letter X, it will use 4.25. And then I'm going to just look back here to my original problem and type that equation. So I'm going to get 2/3 X plus 3/4 times the quantity, 16/3 X minus 9, and the quantity with a parenthesis. Now here, you'd think it says equals, so I should hit the enter button, but you actually don't. There's an equals button on your calculator, and it's inside of second test. So if you notice, the first thing in the list is the equals button, equals sign, so I'll hit the enter button to pull it in. And then I'll continue writing the problem with 3x plus 1/3. Now, to hit enter, it's going to give me one of two things, a 1 or a 0. 1 means that the statement on my screen is true, and 0 means it's false. So a quick little rhyme to remember here is 1 is done, and O is no. So here, if you notice, when I hit enter, I was given a 1, which means, in fact, that the number I found, 4.25, when plugged into the original equation for x, yields a true statement. So I hope this is an example of using your calculator appropriately with an algorithm you should have already known, this 5-step method for solving equations. So I hope this will give you some comfort and direction on how to approach these problems. And feel free to watch it again and practice.